So in this section, you really want to write down in your theory as well a bit about argon diagrams and the argon plane. Okay, this is really very, very similar to the Cartesian plane. Okay, so instead of having x and y for your two axes, we now have the real axes and the imaginary axes for a complex number z. Now remember that z is written of the form z equals a plus bi. So for example, if you have a complex number like, let's say z1 equals -2 plus I, you can see that it's been sketched here by looking at our real part, going across to -2 on the real axis, so going across to there, and then for our imaginary part of z, we've got plus I. Now think about this imaginary as being the plus I going up this way and -I going down this way. So plus I is +1 in this direction, like the I direction, so that's why we're going up to 1 there. And you can see that you've put a dot there where that point is. Okay, you could also label this point either with the coordinate, with the actual complex number, or you can just call it Z1, like that. So with the other ones, just looking at maybe this one here, let's call that one Z2. So we've got Z2 is 2 minus 3i. So again, you can see going across 2, and then that's the real part, and the imaginary part is the -3 down on that axis, so going down to -3, okay, and then across to put your point. And again, if you wanted to, you could just label that as Z2. Right, it's often easier to just label them as Z1 or Z2 because you might have quite a few points on your graph, and then you can fit them in more easily. Okay, so over in example 5, we're just going to sketch a few of those. Now you can actually pause the video here and have a go at sketching them before I do to see if you get them in the right spot. Okay, the first one that we've got here, I'm actually going to call these different things. Z1 is going to be my first one. I'm going to call Z1 2. Okay, I'm going to make sure that I label my axis, so the imaginary part of Z and the real part of Z. And now that I know what Z1 is, it's only got a real part 2, so it will actually just sit right here at Z1 equals 2. So I'm just going to label that as Z1. Okay, so I know that that's there. For B, we've got -3i, and I'll call this Z2 equals -3i. And again, we've got no real part here. This is a purely imaginary number, so we only have to go -3 down in the I direction. So that will be where Z2 is. So doing them all, they're all very similar. Z3 is going to be 2, take away I. It's got two parts, a real and an imaginary. The real part is 2, and the imaginary part is -1. So it's going to be down here. So that's Z3. For D, which is Z4, you can see that you've got a negative outside the bracket. It's a good idea here to actually expand your bracket out. So expand the negative across both terms so you can see more clearly where that will sit. So Z4 will be at -2 and down -3, so it will be there. That's Z4. And the last one that we've got, E, is Z5, -1 plus 2i. Now if you look in the textbook, -1, which is there, plus 2i, so it's up there. They've labelled them as well with the coordinate with the actual complex number instead. Either way is correct. As long as you've actually stated what these Z1s and Z5s are in your diagram, then it's fine to do it that way as well. I just find it's a bit neater to do it this way. So that's using the argon plane to actually show where a complex number sits.